Let's take a look at this example. This time we're supposed to solve this problem. I mean, we have to find these quantities using the nodal analysis. Anytime you are going to approach the problem, which is supposed to solve by nodal analysis, you're supposed to check how many nodes we have in the circuit. In this circuit, we have two nodes. Okay, this is my node 1, and this is my node 2. One of them you're supposed to connect to the ground, and this is going to be your reference node. Okay, so this is my reference node, and the remaining one I'm going to call V1. I'm going to label V1. Okay, so this is my node 1, which is going to be grounded, and this is my another node which is labeled V1. Okay, next, what we're supposed to do? We're supposed to write the formulas. Okay, so please notice that we have to look at the current. Okay, this current I is going to be equal to the sum of the currents. Current I1, which goes through the resistor R1 and the voltage source, and the current I2, which will go through the resistor R2. That's why I'm going to write that I is equal I1 plus I2. Okay. Now, someone is going to say, okay, but I do not have I1 and I do not have I2. So we have to write the formulas. I1 is the current which goes through this resistor. This is nothing else, just the difference of these two voltages divided by this resistance. So this is V1 minus voltage source over R1. Okay, so this is my formula for I1. Next, I'm supposed to find the formula for I2. I2 is nothing else, just voltage between these 2 points, which is nothing else, just V1 divided by R2. So V1 divided by R2. Next, we're supposed to use all these formulas to write the equation. So we have I is equal I1, which is V1 minus voltage source over R1 plus V1 over R2. I can rewrite this as I is equal V1 over R1 minus Vs over R1 plus V1 over R2. Now we are going to rewrite this equation. I'm going to move everything from the right side to the left and from the left to the right. And at the same moment, I'm going to factorize. So I have V1 and V1. I'm going to factorize V1 from these two fractions. So I have V1 times 1 over R1 plus 1 over R2, okay, minus Vs times 1 over R1, and this is equal I. Now I'm going to plug in the values into my equation. So I have V1, and I have 1 divided by R1 has value of 2 kilo ohms. I'm going to write over here 2 kilo ohms, plus 1 divided by R2, which is equal 5 kilo ohms, close parenthesis, minus voltage source, and I have 1 over R1, which is equal 2 kilo ohms, and everything is equal I, which is equal 3 milliamps. Okay, if you are going to look at the diagram, you are going to see that R is equal 2 kilo ohms, Vs is equal 9 volts, R2 is equal 5 kilo ohms, and I is equal 3 milliamps. Now I'm going to use the calculator to find the values inside of the parentheses. So I have 1 divided by 2 exponent 3 plus 1 divided by 5 exponent 3. This is equal 700 microsiemens. So this is 700 microsiemens. Remember, 1 divided by resistance is equal Siemens, okay? So we have minus voltage source, 1 divided by 2 kilo ohms, 1 divided by 2 exponent 3 is equal 500 microsiemens. So I have 500 microsiemens is equal 3 milliamps. Now please realize that we could write 9 volts instead of Vs, but you can do this right now. So now we have to solve this equation for V1. So what I'm going to do, I'm going to simply write that this is V1 times 700 microsiemens. I'm doing everything step by step for those of you who have difficulties with mathematics, equals 3 milliamps, I have 3 milliamps, plus voltage source times 500 microsiemens. We said that voltage source is equal 9 volts. I'm going to write this down over here. So I have 9 volts times 500 microsiemens. Okay, so I have V1 700 microsiemens is equal 3 milliamps. Okay, 3 milliamps plus 9 volts times 500 microsiemens. So I have 3 exponent 3 negative plus 9 times 500 exponent 6 negative. This is equal 7.5 milliamps. So this is 7.5 milliamps. Okay, so if you want to find V1, you have to divide both sides of the equation by 700 microsiemens. Okay, so this one and this one will cancel out, and I have V1 equals 7.5 exponent 3 negative divided by 700 exponent 6 negative equals 10.71 volts. So this is 10.71 volts. Okay, so this is the value of the voltage between this point and ground. Okay, so this is, other words, voltage across resistor R2 and voltage across this whole branch. So next I'm supposed to find I1, I2 and power at resistor R2. So we found V1, so let's find I1. I1 is equal V1 minus voltage source over R1. We have formula already over here, right? So let me use this formula again. So I have I1 is equal V1 minus Vs over R1. Remember, always write the formula first. So V1 is equal 10.71 volts over R1, which is equal to 2 kilo ohms. Of course, minus voltage source, minus 9 volts. Okay, so this is equal 10.71 minus 9 is equal divided by 2 exponent 3. So this is equal 855 microamps. So this is 855 microamps. Okay, so this is the current which goes through the resistor R1. Next, we're supposed to find the current I2. I2, again, I'm going to look at my formulas. Formula for I2 says I2 is equal V1 over R2. So let's use it. So I have V1 over R2, where V1 is equal 10.71 volts over R2, which is equal 5 kiloohms. This is equal, so I have 10.71 divided by 5 exponent 3. This is equal 2.14 milliamps. So this is 2.14 milliamps. Okay, so this is the current which will go through the resistor R2. Next, the problem is asking me for power which is going to appear across resistor R2. The formula for power says P2 is equal I2 squared times R2. Okay, so this is equal, I2 we found is 2.14 milliamps raised to the second power times R2, which is equal 5 kiloohms. This is equal 2.14 exponent 3 negative to the second power times 5 exponent 3 equals 22.89 milliwatts. So this is 22.89 milliwatts. Now I can say that the problem is solved.